Hello, Caymans. I'm Mr. Eicher. We're learning about rational expressions in this chapter, and particularly in this lesson, we'll be talking about multiplying and dividing rational expressions. So let's get started. As a warm-up, I'd encourage you to pause the video and see what you know and what you don't know about multiplying and dividing fractions. And I'll encourage you to see if you could figure out two different ways to multiply fractions. These are the exact same set of products, and see if you could figure out two different ways. And then here's another one. When we're talking about rational expressions, this kind of thing is what we're talking about. So see if you could simplify those, just make a conjecture, and go ahead and pause the video and do that. So one approach when you are working with fractions, you could multiply across, multiply the numerators and you get 60, multiply the denominators and you get 30, and then you can simplify or reduce after that. So that answer would be 2. Another approach you can do when you're multiplying fractions, you can divide out common factors. And you can divide out common factors vertically, like 20 and 6. You could simplify that first. You can also divide out diagonally. So you could divide this 20 and this 5, and you'd get a 4 and a 1, dividing 5 out of 20. And then you could divide this 6 with this 4, so that would be a 2 and a 3. The only negative part about this approach is it gets kind of messy, and it's hard to keep track of everything, so it's easy to forget something. But once we've simplified, actually, we can take this 3 and this 3, we can divide those out. So it looks like the only thing that's left is 2 over 1, which would be an answer of 2, just like we got on the previous approach. So what's going to be most common is actually something like this approach is going to be really common. We're going to factor and then divide out common factors. You can use either one of those approaches on these next two. So you could multiply across. So if I did that, I would have 18 x cubed yz. And in the denominator, I'd have 12 x y squared z. So multiply everything across, and then we could divide out common factors, divide out vertically, so the z's divide out. This x cubed is going to divide with x to leave us x squared. And this y divides with y squared to get a y in the denominator. And then the 18 is, let's see what we have so far. 18 is 6 times 3. 12 is 6 times 2. And we have an x squared in the numerator and a y in the denominator. And then you can see pretty clearly that the 6's divide out. So we'd have an answer of 3x squared over 2y. And then the last one, you can only divide out common factors. So this entire binomial here is going to divide with this entire binomial. So those are going to divide out, and then the t squareds are going to divide out, and you're left with 3 over 1, which is 3. So that was our warm-up. Now let me generalize about what you were just doing. A rational expression is a quotient of two polynomials. So we're not going to have like square roots in this lesson or in this chapter, because the square root isn't a polynomial function. And when we say quotient, we just mean it's a fraction. So this whole lesson, we're going to be talking about fractions. To simplify rational expressions, you factor the expression first, and then we divide out common factors. And that's basically what we were doing in the warm-up above. And lastly, when is a rational expression undefined? That's when the denominator is equal to 0. These are called excluded values. So I'd like to practice both simplifying and excluded values on the next couple examples. So let's look at 1 and 2, and number 3 will be for you as a try this. So in number 1, we need to factor first. So we need to factor this trinomial and also factor this binomial squared, that binomial x squared minus 9. So if we factor those, we have the 5x still sticking around. The x minus 5 still sticking around. In the denominator, to factor a difference of squares, we would have x plus 3 and x minus 3. And see if you know how to factor that trinomial in the numerator. You should get x plus 3 times x minus 1. And then we can divide out common factors. But before we do that, for what factors or for what values of x would this fraction be undefined? So the excluded values, to determine what the excluded values are, you would state each of these factors cannot equal 0. And this is probably something eventually you'll just do in your head, but I'll write it all out for you. So x minus 5 can't equal 0. If it did, if this were 0 right here, if this were a 5, this whole thing would be a 0, and then you'd have division by 0, which is undefined. Doesn't make sense mathematically to divide by 0. So your excluded values, x cannot be 5, x cannot be negative 3, and x cannot be 2. Those are your excluded values. To simplify, we would divide out common factors. These x plus 3's are identical, so you can divide those out. And that's it, actually. So it looks like our final answer would be 5x times the quantity x minus 1 divided by x minus 5 times x minus 2. So this is our final simplified answer, and these are the excluded values. The excluded values we state at the very beginning. So even though there's not an x plus 3 factor anymore, we would still include x cannot equal negative 3 as one of the possible excluded values. Number 2, we need to factor the trinomial in the top and factor the trinomial in the bottom. So if you'd like to pause the video and see if you could factor those and then state the excluded values. So factoring in the numerator, we would get y times y is y squared, and we'd have a negative 4 and a plus 3. That would multiply to negative 12 and get us to positive. Oh, no, we need a positive. So that would be a plus 4 and a minus 3. There we go. And then in the denominator, we'd have a y minus 3 and a y plus 2. That should multiply to negative 6 and get us to negative y in the middle. So our excluded values is that y cannot be 0. That's from this factor. Y minus 3 cannot be 0. That's from that one. And y plus 2 cannot be 0. That's that one. So we'd have y can't be 3, y can't be negative 2, and y can't be 0. All those would be excluded values. So we would have, simplifying now, the y minus 3's are going to divide out. The single y here divides out, and that looks like that's it. So we have 4 y plus 4 divided by y plus 2. So that would be our answer. You do not need to distribute, but if you did, you would get 4y plus 16 over y plus 2. So we'll put or there. I have number 3 for you as a try this. So if you'd like to do it now and save yourself time later on Schoology, you can do that. Let's move on to number 4 and number 5. It says simplify only, meaning we don't have to state the excluded values. So we need to factor. Notice the denominator here is a difference of 2 squares. So factoring that, we would have in the numerator is the exact same thing. In the denominator, though, we would factor a difference of 2 squares as y times y is y squared. and x times x is x squared. And since we have a negative, we need opposite signs. Now the thing to note here is this factor, x minus y, is not the same as this factor, y minus x. Let me just give you a little detour here. Let's say x is 3 and y is 5. Let's just say. So x minus y would be 3 minus 5, which is negative 2. Y minus x is 5 minus 3, which is positive 2. Notice those are different, but they're the same number, just opposite signs. So what we can do is, here's the thinking here. What we can do is we can rewrite this one in the denominator so it looks the same, so it's x minus y. But to do that, we would have to make it, let me rewrite the numerator. We would have to make it a negative 12, and then I can flip the order of the subtraction. So again, notice this changed from earlier because I can do that by making it a negative. So then we can divide out common factors. Y minus x minus y is the same as this x minus y now. 30 and 12, I think that would be a 5 and a 2. So then it looks like our answer would be 5x over negative 2y plus x. And we put the negative in the top, so that would be negative 5x over y plus x. And that would be our simplified answer. We could do the same on number 5. Notice in the numerator, there are two terms, and they both have a's and b's, so we could take a greatest common factor out. So if we took a b out of those, that would leave us with b minus 5 in the numerator. You can always check your answer by distributing this back in and see if you get back to where you started, and it looks like we do. The denominator is already kind of factored for us, but notice this b minus 5 is not the same as 5 minus b. So we have to use that same tactic of pulling out a negative. So that would be 5 plus b. I'm going to put a negative out in front here. I'll make it red so you see it. And I'm going to flip this to be b minus 5. So again, notice this changed right here from what it was originally because I pulled out a negative. And then I can divide out common factors, b minus 5. So we have ab over negative 5 plus b. And we put the negative in the top, so that would be negative ab over 5 plus b. So that would be our simplified answer. I'd like you to try number 6 and number 7, and you'll input your answers onto Schoology for those. Thanks for watching this video. That's part 1. Part 2 of the video will be the next page, multiplying and dividing rational expressions. Thanks a lot.